My name's Sam. I'm from a small tech company called Veredictum. You may have heard of us through Tim Lee, our CEO up the back. I've been working with Tim for about 10 months, whilst I was also working at a major financial institution. I've been working full-time on blockchain technology now for about 2.5 months, and tonight I want to give you a bit of an update about what we've been working on in the sort of anti-piracy, video anti-piracy space. So a little bit about me. I have a background in electrical engineering, did a couple of tours of duty in financial services, as well as in consulting, energy and utilities, sort of in New South Wales and Queensland, oil and gas. I got introduced to Bitcoin in 2011, but didn't really stick with me. I was sort of interested in some other things at the time, but about 3 years ago, I was reading about a little project called Ethereum, and my interest was reignited. I've been following that project ever since, and I've been following blockchain ever since then as well. So my talk tonight is really to give you, first of all, a bit of an overview about what Veredictum is trying to achieve, and just to zero in on one of our, the design of one of our products that we are in the process of designing at the moment in order to achieve some of our goals. Video piracy takes a lot of different forms on the internet. Obviously, you've got your peer-to-peer file sharing. That's your things like downloading movies off the Pirate Bay and so forth. You've got freebooting, which is what we'll be talking about tonight. That's where you have videos that are taken from independent content creators that are put up to the likes of YouTube and redistributed to other areas on the internet. And you've also got live piracy as well. So these are things like people sitting in a movie theatre, live filming on their phones, perhaps live streaming to Facebook Live, or sitting in some sort of live presentation and pirating that material in real time as well. So Veredictum's overarching goal is to have a significant impact on video piracy. And we really take, at a high level, two sort of key views on that. The first one is to improve the technology to inhibit piracy. So that's building technology to stop piracy from occurring, but also to investigate ways that we can improve the distribution of content so that consumers can access content when they want to at a price point that's reasonable. Because we believe that most of the time, for people who casually pirate stuff, that's the main reason why it occurs. We can't access it, and if we can, it's at a price point that's just way too high and unreasonable. Okay, so I just really wanted to zoom in on the freebooting side of things, because that's what this talk is really about. And I wanted to play a video by an independent YouTube creator who has created a YouTube video about this very problem that was pirated. In the video, he mentioned that YouTube's content ID system works quite well for content on YouTube. So if content from one YouTube creator has been taken and uploaded again onto YouTube, there's an internal system on YouTube that actually does a pretty good job of picking that up. But there's no linkage back to another system if it gets moved to Facebook. So that's part of the problem that we're going to be narrowing down in on. I personally really love YouTube. I've got over 120 channel subscriptions. That's the sort of stuff that I watch every day. So I personally feel pretty passionate about this. I want to see more value flowing back to the content creators so that they can create more quality content. And that's the underpinning argument. So how is Veredictum planning to address this issue. So the problem that we're trying to solve is how do we inhibit, or how do we detect and rectify the problem when a file has been taken from one section of the internet where it's supposed to be and it's uploaded to another section of the internet where it's not supposed to be. So the tool that we're designing at the moment is effectively a search tool for content, and it relies on a combination of distributed computing and blockchain technology. To set the stage, the first thing that's required is to embed each piece of content that a content creator creates with a unique identifier. So this occurs via a process called steganography, where you can process a raw file and come up with a new file. Embedded in that is an ID that is completely invisible and inaudible to anyone viewing the video. So using our technology, you would view that video there and you would have no idea that it's actually got a unique identifier in there that links back to the identity of the content creator. So to sort of take you through the use case, a content creator would log on to our system, that would create an identity, that would create a private-public key pair. That public key would then be associated with a range of IDs that represent the pieces of content that they have registered. Each ID linking into a piece of content and having that registered immutably to a blockchain. So once you've got the ID embedded into your piece of content and you've distributed it to the likes of YouTube, the next problem you have to solve is, where has my content gone? And of course, in the video, it's not actually possible to search for content on Facebook, to search for files. So the second product that we're designing at the moment is effectively this distributed content search tool. And it takes these steps to actually achieve that. The first step is to watermark the file linked into the identity. We then index the search area of the internet, sort that search area, break it up into a number of pieces, and provision those pieces out to a distributed computation network. Those nodes in a distributed computation network process and cross-validate those files. And once the process has been validated, at the end, we basically get a binary answer, a yes or a no. Was that search space, did that search space contain any IDs that linked back to that public key and therefore are owned by an independent creator? That's the telemetry part. So to take you through it in a little bit more detail, these are just a bunch of diagrams I took out of our white paper yesterday. So effectively, white hat content creator uses our service to transcode, uploads it to YouTube, and that's where it stays. That's where it's supposed to be. That's where it generates revenue. That's where some of the value comes back to the content creator. Black hat actor steals from YouTube, uploads to Facebook for whatever reason. So the second step is to index that search space. This is quite a large search space. I've done some calculations on this. If you actually have a look at how much information is uploaded to to Facebook every day, it's of the order of about 300 terabytes. So that's the sort of quantum of data that we're looking at. Step 3, sort the information. So if we just restrict the problem space to Facebook only, our 300 terabytes, index that search space. So over one time period, say 1 day, we can gain an understanding of all the different files that were uploaded and get a profile of those files. We then run through that unordered search space into an ordered search space using some algorithm. You can, like, there's a number of things that you would need to do in order to sort the search space. So one of the things you might need to do is remove files that are, say, less than about 8 seconds, because that's too short a time period for our decoder to unwind that file and actually pick up an ID. You might also want to use some Bayesian techniques. So if you've downloaded a number of files from a Facebook user who has previously uploaded pirated content, then you would want to prioritize those files in the ordered search space. So you got your ordered search space. The second thing you need to understand at this point is, what does your distributed computation network look like? So you've got a pool of nodes. Each of those nodes are willing participants in this distributed computation network, and they, according to this design, would need to submit to the protocol some information regarding how much processing power they've got, how much electricity they'd like to spend, what's their bandwidth budget, what sort of times they want to process. The other thing they would need to do is make a deposit, and this is important for sort of game theoretic reasons, for the validation of the computations that they perform. So once you order the nodes and you group them into small groups, I've got a small group of 3 here. What you end up with is an equivalent stack of subnetworks, each of which will compute a small portion of the ordered search space. Is everyone with me so far? Any questions?
Who owns the nodes?
Anyone. So it's...
We're renting them from you, or we're renting your middleware to allow us...
So it would be so it would be just a distributed application. You could download it and run it on your MacBook Pro overnight if you like. And I've actually modeled this off hardware that creatives might use. So the idea being is that these participating nodes would in fact be the same network who are affected by piracy. So independent content creators with desktop computers and laptops and so forth.
So if I'm a content creator, I can rent at specific times. I can go in and check using your mechanism to then go do searches, or is it something that I, as a subscription, start up and keep running and then report that?
Right, so there's 2 different types of actors. There's the content creator who wishes to pay for the search, and then there's the node who runs the application on their computer and doesn't do anything about it besides submitting some information, who gets paid to perform that search, perform that service. So these nodes I've got represented here. They are logically 2 different actors, but they could be the same person in reality. So the next step, once you've got your ordered search space and you've got you've got an understanding of how much processing power is in the network, and you've got your stack of subnets, you can then provision. You can break up your search space. You can provision it into a sensible number of partitions, and then you link up your ordered search space and your ordered stack one-to-one until eventually you run out of search space or you run out of computation power.
Who allocates the search space to each node?
So that's who allocates. So the allocation is sort of handled by the fact that you have petitioned up the search space, but you mean the indexing and then the ordering?
Yes. For example, if I run a node, how do who gives me the information that which video to take to analyze?
That would be done by the protocol. So it's not. It's programmatic and it's managed by Veredictum.
So it's not looking for specific files, it's looking for any files that are configured.
No, it's looking for specific files. So the protocol will tell you which files to download and process. Yeah.
Is the protocol centralized or the nodes collaboratively find out?
The protocol is effectively centralized. Yep. So the reason why you would do it like this is because you would either run out of search space or run out of processing power first. And obviously, you kind of need information about both in order to optimize the entire system. So if you've got more processing power, if you've got surplus processing power, it means your search space can broaden to beyond Facebook or to Instagram or whatever. So then, as the nodes process their search space, they run the application that they would download and at regular time intervals submit their state to a blockchain. So you remove the trusted aspect in order to compare the states of the nodes.
In that graphic, are your lines individual files that node is found in that blockchain?
So the first one is like the first time period, and that's the state at time period 1. And that's the same for all three. So node 0 time period 1, node 1 time period 1, node 2 time period 1.
So there's node 1.
And that's compared.
Yeah, but node 0 through 2 have found the same file and have formed consensus and then written to the blockchain?
Exactly.
What happens if they don't find the same file?
Okay, I'll ask that question in a minute. So this is the happy path. This is assuming that given the game theoretic design, all of the 3 nodes at all of the time periods, so there's 3 nodes, 4 time periods, 4 time periods, because that would be the first time period, that would be the second, third and fourth. They all agree on their internal state at every point in time, is the happy path. And then finally, the final result is compared. So if all of their internal states agree, then they've all performed the computation exactly the same. And so their final state, which is the final result, will also agree. That final result, so the list of IDs that was found for that provisioned sector of the search space is then written again to a blockchain, which can then be queried by an external application to tell the original requester, which was your question, what the result of that search was. So over the time period, in this case 24 hours, you would find out that information, and then that actor who originally requested that search could take some action. So they could manually send that takedown notice to Facebook, for which they're required to comply according to the DMCA, or we're actually working on a tool to automate that for them. So they'd pay a small fee, perform the search, and then any infringements that were found would be automatically sent to Facebook, and Facebook would be required to take them down.
So in cases where the video was technically stolen twice, but has 2 separate IDs, it doesn't matter because your nodes are searching your fingerprint, not the link that Facebook is providing. So a single video that has been pirated more than once
would have a different location on the internet and would be found twice. So if it was,
are you getting a cumulative to the blockchain? Are you getting a cumulative summation of the amount of times spin?
Yeah, definitely. Yeah. So I suppose that this assumes, and I'm pretty sure you can do it, that you can uniquely identify the file based on things like upload date, user. Facebook has a file ID itself, so you've got an idea of the file, but you don't have any idea what's inside the file. That's what this is doing. It's actually looking inside the file and providing information back to the requester. Okay, so that's basically how it works. But there was a question here from Adriana about what happens if you don't go down the happy path. So I've got another slide here. So this is a graphical representation of the TrueBit protocol. This is one way in which you could resolve disputes. In order to verify the computation, the nodes within the subnet agree on the final result by majority consensus. So 2 out of 1, if 2 out of 3 vote that it's actually one thing and not the other, then it's actually the thing that the 2 vote on. However, if the third node really disagrees that that's the case, and they think that the other 2 nodes colluded, then they can enter into what's called a verification game, which is basically a subroutine which sort of sits over the top, which allows for dispute resolution. It effectively works like a binary search. So you reperform the challenger, in this case, say node 2, saying that node 0 and node 1 did the wrong thing, will challenge those nodes to reperform the computation. And over a series of iterations, the computation will narrow in on the state change that the nodes disagreed on. In the case that they disagreed on the very first state change, then it would obviously narrow in on the first state change. Until such a point in time where that computation is sufficiently trivial that it can be exported to a trusted execution environment, i.e. Ethereum, run it on a blockchain, and that would arbitrate between the 2 states. Is it one or is it the other? And depending upon the outcome of that, the deposits would either go to one or the other party. Does that make sense?
Yep.
Okay. Ron.
It seems to me that it sounds a bit like the sort of thing that people are doing study at home, for example.
Yep.
Sort of passing out to a lot
Yep.
of people the same computation and verifying that the computation has been done correctly. But for what you're doing, it sounds to me like what you're interested in is detecting multiple instances of the same fingerprint. Okay?
Yeah.
And that's sort of, once somebody has found that, they can just present that evidence, and that's very easily verified just by sort of checking on that.
Yes, it's falsifiable. Yeah, you
So
can.
It's not like you've done some very complicated computation. You don't trust whether people have really done the work for you. You can check by the result that they return that the work has been done correctly.
Quite easily.
So are you doing more than just that sort of thing that you could do with a very simple check on the output?
You could do more. This is just the first step. Yeah. So.
I mean, you're wanting to have a platform that does sort of like the sort of study at home.
Yeah. The problem. That's right. This is fun. So, Ron mentioned study at home. This is fundamentally different to academic style distributed computation, because that I don't think actually does the verification step. So verification, there's no cryptographic trick that you can perform. The reason why you have to do the reperformance, so the reason why you have to reperform the computation in order to verify the computation, is because there's no easy, well, there's no cryptographic way that we have invented yet in order to prove some remote program that's run on someone else's computer. So that's why you have to perform the same computation in order to verify that they've done it faithfully. Does that make sense?
I think Professor Wong's point is that in order to prove I have detected a privacy, I only need to prove one video that is private. I don't need to prove the rest of the work that I have done for the authentic videos.
Sure.
So even if it's a fully replication of the computation, it's still relatively cheap. Is this what you mean?
Yeah, I mean, verifying the output here is cheap. I mean, you can do that just on the basis of what the output is.
You mean after this is completed?
Computation.
You want to pay people whether they find something or not, right?
Yes.
Yeah. So he wants to pay people regardless of whether they find something. So you need to verify they're actually doing work.
Ah.
My understanding.
Yeah. Yes. It's
So it's not proof of work, it's proof of stake, technically.
we call it proof of discovery, but it's.
There were people who didn't find any piracy.
Say again.
There were people who didn't find any piracy.
Yep. So that's still a positive result. So the requester is actually paying for the knowledge that their material is either there or not. And if they get a result that says, "Hey, we didn't find anything," that's still a good outcome. We call it proof of discovery, but it's not a cryptographic proof the way a cryptographer would understand it. It's a probabilistic proof. So we can prove to within a level of confidence that that result that we've produced is correct.
What if most of the provers is myself, and I work with myself?
So we select the nodes at random.
Yes, but I populated the network with my nodes.
There's
a good chance that is myself.
Yeah, that's an attack vector for sure. That's something we would need to make sure we design around. There was a question at the back.
What chance is that, in commercial terms, that the cryptographers can outgun you?
So that they can remove the ID embedded in the file. Yeah, good question. So the technology that we've got is pretty resistant to transformation. And this is not about reducing the problem to zero. This is about reducing the problem by like 70, 80, 90%. So our position is that, sure, there's going to be people out there who are going to try really hard and probably be successful in a small percentage of cases to defeat the safeguards. I can tell you though that the steganography tech that we've got is pretty cool. In the lab, I can take a video on my smartphone of a video that's playing on a screen, and that'll easily retain the ID. So even though the new file is a different format, it's got different bit rate, it's got different frame rate, all these sorts of things, it still retains the ID. So the only way, well, a really good way actually for defeating the technology is to reduce the file to something that is almost inconsumable by a person. So reduce the frame rate to something that looks bad and that sounds bad as well. But in that case, you've also destroyed the thing that you're trying to achieve. So yeah, it's quite nice.
So how about a video chopped into some pieces and then joined again, and so does that identify ID again? Tampering with the bit rate and everything is fine, but
Yeah.
your video is end to end.
Yep. Look, I've tried to break it. I can't really break it.
So
It works pretty well. Look,
If you know it's there though, you can remove it. If you know exactly how it's put there, is it removed? Throw it away.
sounds like a challenge. Yeah, if you figure out a way, let me know. I'll give you a bug bounty, how about that? Another question, sorry.
One more question. The stenography, do you guys own that IP or are you licensing it?
That's a very good question. It's a little bit of both actually, so maybe we can talk about that.